Have you ever wondered if we are alone in the universe? It's a huge question. For a long time, we could only dream about the answer. NASA decided to do more than dream. Their journey began decades ago, not with giant telescopes, but a simple, hopeful idea. In the 1970s, they launched two amazing spacecraft, Voyager 1, Voyager 2. These probes were built to visit the giant outer planets, Jupiter, Saturn. Then they kept going, into interstellar space. NASA scientists added something extra special. They attached a time capsule, a message in a bottle. These are called the golden records. Gold-plated copper discs, like old-school music records. They contain sounds and images that tell the story of life on Earth. Greetings in 55 different languages, sounds of wind and rain, the cries of animals, pictures of people, places, scientific diagrams showing our location in the galaxy, our first real attempt to say hello to the cosmos. The Voyager missions were a spectacular success exploring our solar system. They sent back breathtaking images of Jupiter's swirling storms and Saturn's magnificent rings. We learned so much about the planets, but the golden records represented something more. They showed our deep-seated hope and curiosity. After sending our messages out into deep space, NASA turned its attention to a much closer neighbor, Mars. The red planet has fascinated humans for centuries. It's the one planet in our solar system that looks a bit like Earth. Early telescope observations even made some people think there were canals built by intelligent Martians. So, NASA decided to go have a look. Viking 1 lander, 1976. Viking 2 lander, 1976. Robotic laboratories tested Martian soil for signs of life. An incredibly ambitious plan for the time. The Viking landers were technological marvels. They scooped up Martian dirt and ran experiments inside their science bays. The goal was to see if there were any tiny microbes, or germs. The results were puzzling, and at first very exciting. Some experiments seemed to show chemical reactions that could be caused by life. The soil seemed to be active, but other instruments found no evidence of organic molecules, the building blocks of life. Scientists debated for years. The likely cause was strange, non-living chemistry. Viking taught us so much despite no definitive proof. We learned the Martian surface is harsh, cold and dry, blasted by radiation from the sun. Life seemed unlikely on the surface today. NASA changed strategy. The new motto, follow the water. On Earth, wherever there's liquid water, there's life. So search where water might have existed in the past, or where it might be hiding underground. A new generation of explorers was needed. The era of the Mars rovers began. Sojourner, 1997. Spirit rover. Opportunity rover. Curiosity rover. Rolling robots explored Mars like geologists. Curiosity landed in 2012. It's the size of a small car and carries a powerful suite of scientific instruments. It found clear evidence Mars once had flowing rivers and large lakes. It discovered an ancient lake bed that would have contained the right ingredients to support simple life billions of years ago. We haven't found fossils yet, but we found a place where life could have been. While rovers were digging in the Martian dirt, another group of NASA scientists was looking much, much farther away. They were trying to answer a huge question. Are there other planets like Earth out there? For a long time, we only knew about the planets in our own solar system. We had no idea if other stars had planets orbiting them. Finding these exoplanets is incredibly difficult. They are extremely far away, don't produce their own light, hidden in the glare of their parent stars. It's like trying to spot a tiny firefly next to a giant searchlight. To solve this problem, NASA developed amazing new technology. In 2009, they launched the Kepler Space Telescope. Kepler's mission was simple but brilliant. It would stare at one patch of sky containing over 150,000 stars without blinking for years. It searched for tiny, periodic dips in starlight. What could cause that? A planet passing in front of the star. This is called the transit method. Every orbit, when a planet crosses our line of sight, it blocks a tiny fraction of starlight. Kepler could detect those minuscule dips. The results were revolutionary. It was a game changer in our search for life. Kepler discovered thousands of exoplanets. Planets are incredibly common in our galaxy. Most stars probably have at least one planet. Kepler found many planets that are small, rocky, in the habitable zone of their star. The habitable or Goldilocks zone is the region around a star where the temperature is just right. Not too hot, not too cold for liquid water to exist. Kepler transformed our understanding of the cosmos. Before Kepler, we only guessed about other Earth-like worlds. After Kepler, we knew the galaxy was teeming with them. Suddenly, the odds of finding life seemed much better. We went from one known solar system to likely billions in the Milky Way alone. Kepler's mission ended, but it passed the torch to newer, more powerful telescopes, giving us a catalog of exciting new worlds to study in our ongoing quest. While the search for distant Earths was heating up, other NASA missions were making shocking discoveries much closer to home, in our own outer solar system. The Galileo spacecraft, which orbited Jupiter in the 1990s and early 2000s, sent back stunning data from Jupiter's moons. One moon in particular caught everyone's attention: Europa. At first glance, Europa looks like a giant, icy cue ball covered in cracks. But Galileo's data suggested something incredible might be hiding beneath that thick ice shell. The magnetic field data just didn't make sense unless there was a layer of something electrically conductive, like salty water, underneath. This was a groundbreaking idea. Could there be a massive global ocean hidden on Europa? An ocean with more water than all of Earth's oceans combined? The possibility was, well, tantalizing. On Earth, we have discovered entire ecosystems deep in our oceans, clustered around hydrothermal vents. These vents spew out heat and chemicals from the planet's interior. Life thrives there without any sunlight at all. If Europa has a warm, rocky seafloor and a liquid water ocean, it could have similar vents. This means Europa could potentially harbor life, completely independent of the sun. It opened up a whole new place to look for living creatures. The discoveries didn't stop at Jupiter. The Cassini mission, which explored Saturn and its moons from 2004 to 2017, found something even more dramatic. It flew by a small, icy moon called Enceladus. And what it saw was, honestly, breathtaking. Giant plumes of water vapor ice particles were erupting from cracks near the moon's south pole and spraying out into space. Cassini was able to fly right through these plumes and taste them with its instruments. It found water salts, simple organic molecules, the very ingredients for life as we know it. We were seeing a hidden subsurface ocean actively venting its contents into space. These discoveries on Europa and Enceladus have completely changed our perspective. Life might not need to be on a warm, rocky planet like Earth. It could be thriving in the dark, cold depths of a hidden ocean on an icy moon, miles from the warmth of the sun. This has made these moons some of the most compelling targets in our solar system for future exploration. NASA is now actively planning missions to go back and investigate these ocean worlds. The search for life is no longer just about following the water. It's about drilling through the ice to find it. So, where does the search for alien life stand today, in 2025? It's more exciting than ever, with powerful new tools at our disposal. Right now, the James Webb Space Telescope is giving us our best look yet at the atmospheres of distant exoplanets. When an exoplanet passes in front of its star, a tiny bit of the starlight shines through its atmosphere. The James Webb can analyze that light and look for the chemical fingerprints of certain gases. It's searching for biosignatures, gases like oxygen, methane, water vapor. Finding these gases together would be a huge